All right, so here we begin to talk about exactly how these things encode text and use it. So BERT is one of the encoders for languages, a pre-trained one, and this takes words. This is how large language models understand language. So you feed in words, it makes tokens out of them, which are usually just one token per word, and then it just assigns them code numbers. And it adds a few extra tokens, like this one is the start of a sentence, and we're going to see a few others. Then each token is then embedded in a 768-dimensional space. And this is something that sounded like magic to me, and I was very pleased to finally understand it. This is a meaningful mathematical representation of the meaning of a word. And I said, how did you do that? Did you hire humans to somehow classify all the words in a dictionary? And they didn't, of course. What they did was this. You have sentences here. Napoleon revolutionized military organization. Napoleon has legacy. Legacy still lives. So those are the words. Then we're going to tokenize them. So here it says a start. It has a period with a special token. It has the end here with another token. And that's it. It has now broken these sentences and turned them into numbers. Now these numbers are just arbitrary and meaningless, but the same word appearing again will have the same token. Napoleon is the 8891 in both cases, and so on. So that's good. Now it does masking. You take 15% of the tokens and mask them. You take them away. So when you mask them, now you have Napoleon revolutionized military organization, but these two have been tokenized as 103, which is a mask. So those words are missing. The eyes is a part of a word treated separately. The tokens are not always exactly one for one to words. Things like extensions like that on the end of a word are sometimes treated separately. So now 3 of these tokens have been removed. And now you train the model to predict the missing word. This is what I said before. Look at the picture of the cat right at the start. I've now made a supervised learning task out of an unsupervised learning task. Now I know the right answer, so I'm going to let it practice trying to predict the masked word. So here is the simple one, artificial intelligence mask take over the world. And here's the weights. It has a 30% chance of being can, an 18% chance of being will, a 5% chance of being to, and so on. It has got various words that more or less fit into the context, and it has decided how likely it is. And all it's done is taken its vast amount of data it was trained on, and said, how often would this word fill in a sentence like that? And how often would this word fill in a sentence like that? From its mathematical model of the entire web. So that's how it learns to put words in context so they fit with the words around them. And here's how you sequence sentences. You take the second sentence, and half the time you leave it there, and half the time you replace it with a random wrong sentence. And now you say, tell me if it's the right sentence or not, and you know the right answer to that question, so you can train it. And again, it learns that. This is how you get large-scale coherence in the output. So now we have a model that can make sentences that look good and paragraphs that look good, all without having any idea what any of it means or what it's saying. But it gives the illusion of being written by an intelligent human. So now you can do things. We're going to get movie review data, 50,000 movie reviews that come down with the textual review and the number of stars, and now we're going to do sentiment analysis. Read the text and tell me if it was a good movie or not, based on the paragraphs of data there. So you do sentiment analysis with BERT, and I decide I'm going to call it, I'm going to find how many of them are wrong. So if it calls them positive, but they gave it 1 or 2 stars, I'm going to call that wrong. If it calls them negative, and they give it 4 or 5 stars, I'm going to call that wrong. If they gave it 3 stars, I'm not going to call anything wrong, because that's an intermediate value. And so we can now figure out how good it is, how many it got wrong, and BERT got 6 wrong out of 100 movies, so that's pretty good. And that's an example of the kind of thing you can do here, and all of that without understanding anything. So that's the tokenization part. The next part is the embedding, and I should have that coming right up. That's 127. All right, yep, embedding, 129. Okay, this is the part that really struck me as magic. How do you get a mathematical representation of the meaning of a word? And here's how you do it. Here's how BERT does it. So I have some words here. BERT has a vocabulary of like 20 or 30,000 words, and that's it. And you can just look at them. Here they are, to, was, he, is, as. So those are all the words it knows, and it has been trained to embed them. So we can take this. Here's a couple sentences, or I guess one sentence. After stealing money from the bank vault, the bank robber was seen fishing on the Mississippi River bank. All right, so we can tokenize that, as we did before. So you have a start separator, then the word bank is 2924, and the word bank again here is 2924, and the word bank here is 2924. So it's just assigned them numerical values. Now we can embed these words with BERT. And you embed them, now we can get the vectors representing the tokens. And you'll see the vectors here. And what we're going to do is print the vectors are 768 parameter vectors, but we're going to print the first 5 values. So now you can see this occurrence of the word bank is 3 and minus 3. This is from the bank vault. The bank robber, the word bank also means a house full of money here. So this is 3 and minus 3. But this is the Mississippi River Bank. The bank here is 1.5 minus 1. So it correctly deduced that even though it's the same word, it has a different meaning in context. The vector is pointing in a different direction. And they do this just by training it with masking to know when it's in context and when it's out of context. So again, without understanding anything and without humans doing the work, it has determined which meanings of the word are close to other meanings, and it is so accurate you can do vector similarity. So a boy becomes a man and a girl becomes a woman. You can calculate the vector similarity between boy and man and the vector similarity between girl and woman, and then you can calculate the vector difference between boy and man. And it's the same as the vector difference between girl and woman. So even relative meanings are preserved mathematically here. And it did all that without understanding anything, just by training on the data with masking to calculate the relative differences. So that's what's going on. And that's what I say, if you understand how these things work, you'll understand the risks. They don't understand that talking about a bomb is different than talking about yogurt and food and games and everything else. All of them are just mathematical numbers to them. This is like the classical science fiction thing. The robot has no concept of human values, no idea about right and wrong, no idea about consequences. It doesn't even know that it's talking. It's just doing a mathematical calculation on these numbered words. It looks like words. It looks like it knows something, but it doesn't know anything. And there's a tool here you might want to try, which is easy to make your own retrieval augmented generation. Anything LLM is here. You install this thing called LM Studio. It's a nice graphical tool. I prefer the command line tool because I'm that kind of command line nerd, but most people would rather have a graphical tool. So you can run this thing. This will let you run large language models locally with a graphical environment, and you can then use a chat here. Will AI take over the world? And it'll give you an answer like they usually do. This is Llama 3's answer. Okay, you can run it on your local server. Instead of using the cloud machine, you can run it locally, and then it listens on an API. You have an API endpoint to fill in answers to a question with completion, listening on port 1234. So you can run the server here, and you'll see a text pane down here showing you it going. Now you can add this thing called Anything LLM, which connects with LM Studio. And what this lets you do is retrieval augmented generation. You can now add custom data to the model, which is like, say, what everybody I deal with is trying to do. So now you can get it ready, and now you can ask about a current event. Ask what is the Microsoft Recall feature. Now, Llama 3, which is what we're using, was only trained on data up to March 2023, and Microsoft Recall was announced in May 2024. So there was no Microsoft Recall as far as this model knows. But if you ask it what Microsoft Recall is, it will tell you garbage. The Microsoft Recall allows developers to easily retract or recall previously deployed software updates. It will give you a whole page of really convincing stuff that is all crap. And then if you ask it the same question again, it will make up a different page of complete crap. Like next time I tried it, it says recall will pull back an email message you sent and give you a whole page that looked good about that. It makes up something because it doesn't know what it doesn't know. It has no concept of I don't know. You give it some data, it prints it in numbers, it runs it through its math to predict what words come next. It doesn't have an option that says I don't know. Any input, it can do the math and create an output. And by the way, it will always look beautiful. It will always have good sentences and good paragraphs. It is not aware that it's all lies. It will just make up lies about anything it doesn't know. By design, it's operating exactly as it's designed to. The problem is it never understood anything about the question of the answers. It doesn't know there is a difference between truth and fiction or lies. It never has. It never could. That's the problem. Now, some of the latest models, I think Anthropic's model now has an option to say, I don't know. And I'm interested in how they do that. The intrinsic design of these things does certainly not make that easy. But one thing you could do is you could automatically ask the question 10 times and see if the answer is varying a lot, and then say, maybe that's a clue that I don't know. But that would make it even more expensive. And by the way, this is a huge problem with the whole AI thing. It's all a loss leader, every bit of it. If you pay $20 a month for ChatGPT, they say they're having to pay, I think, $200 a month to run the servers. And now the thinking models, I think they say it is like several $100s for each query to run all the processing. And people are already balking at paying $20 a month. Microsoft can't move Copilot at that price. They had to lower it. They are so far from being profitable right now. But there's hope. This is what I've been saying to my students for the last couple of years. Probably they'll get more efficient. And the Chinese model, DeepSeek, really rocked the boat. They showed you can do this much cheaper, much faster, like China did with a lot of things. We make some big expensive thing and they make a much cheaper version that's just as good. They did it with large language models, even while we're embargoing them. We're trying to hold China back. And this was a disaster. They just decided they don't need us and they're charging ahead without us. We are not holding them back. They appear to be ahead of us. So anyway, so that's a fun thing. So what you can do now, it will lie to you about Microsoft Recall, but then you can add the Microsoft Recall data to it. You can add the current information, like the Microsoft Recall announcement webpage. Then it will process it and tokenize it to put it in the right language. And you can add it to the knowledge base. And after that, when you ask about recall, it will tell you the truth from that page. So that's what you do. And that's what all the companies want. The problem, of course, is it'll be wrong, and it'll be really convincing when it's wrong. And this has fooled lots of people. There's famous stories like lawyers that go to court. Another one happened last week. Some lawyer went to court with a brief full of all these false statements and false references from AI. Because it looks good. I remember there was about 6 months ago, there was a college teacher that said, I keep busting my students. Their essay is written by AI. What I do is I just paste it in there and ask ChatGPT, did you write this? And if it says yes, then I flunk the student. I said, no. It will say yes, even when it didn't write that. You don't understand how this works. He thinks it's got a database and it remembers what it did. No, nothing even close to that. Right now there is no known way to detect AI written stuff. Humans can do it somewhat. There are some tools that work. They don't really work very well. A lot of teachers are trying to identify the AI written stuff to flunk those students, and it's not easy to do. I certainly wouldn't trust any of the tools out there very well. Anyway, so there's some local running AIs worth playing.